Okay, friends, now let us continue this discussion of combination of resistors, and in this, let's talk about the parallel combination of resistors. Now, try to understand this. Here, between these 2 points A and B, let us take these 2 points A and B. Between these 2 points A and B, we have three resistors R1, R2, R1, R2 and R3 connected. Okay. Now, of course, because of the parallel combination of these three resistors, what would happen? Definitely, because of the resultant of the parallel combination of these resistors, some current I would flow through the circuit. Let this current is I. Now, when this current I is coming here and reaching to this point A, what will happen? Now, there are three ways. Either it can pass through this path or this path. So what happens that the current, it gets divided. Suppose I1 current, it flows through this. Okay. I1 current flows through this. I2 current flows through this. And I3 current flows through this. Am I clear? I3 current flows through this. Now, I1, I2 and I3, they will reach to this point B, and here again I1 and I2 and I3, they are added. You know that here I current was actually splitted into I1, I2 and I3, and here I1, I2, I3, they combine to form current I. Okay, current I, right? So this is the I current which is flowing here. Am I clear? Now, what you have to do is you have to actually write the Ohm's law expression for these resistors. And for that, what we are doing, you know that V potential differences produced across these 2 points A and B. Okay, do remember that between these 2 points only, these all resistors are actually connected. Okay, and if these resistors are actually connected between these 2 points only, so potential difference across this resistance R1, potential difference across this resistance R2, and potential difference across this resistance R3 is same potential difference is actually produced, same potential difference is actually produced, and that potential difference is V. Okay, now because of this potential difference which is produced across R1, what will happen? You know, we can apply Ohm's law here. So let's apply Ohm's law. So by Ohm's law, let's apply Ohm's law here. So when we apply Ohm's law, what will happen? By Ohm's law, what we can do is, this V is the potential difference which is applied. So we can write V is equal to IR. What is I? I1 current is flowing through this this resistor R1. So I1 times R1. So we can write I1 times R1 here. Okay. Similarly, we can write V is equals to I2 times R2, because you know that through this resistor R2, I2 current is flowing. Similarly, we can write V is equals to I3 times R3. Correct. So V is equals to I1 R1, V equals to I2 R2, V equals to I3 R3. These are the expressions when we apply Ohm's law in resistance R1, R2 and R3. Let's find values of I1, I2, I3 from here. I1. For I1, what we will do? We can write I1 is equal to V upon R1. I2 is equal to V upon R2, and I3 is equal to V upon R3. Okay, so these are the values of current. I1 is V upon R1, I2 is V upon R2, and I3 is V upon R3. Having said that, do remember this, that in this particular parallel combination of resistors, what is happening? You know, this I current is getting divided into I1, I2 and I3. So what we can do is we can write I is equal to I1 plus I2 plus I3. Okay, now do remember that this parallel combination of resistors R1, R2, R3, okay, because of this resultant of the parallel combination of resistors, what happens that a particular current I, it comes out. Okay, this I is because of, it is coming out because of the parallel combination of resistors R1, R2 and R3. And because it is happening, that's why this particular I current can be written as V is equal to IRP, where RP is what? RP is the parallel combination of resistors. I is what? I is the total current which is coming out of the battery, okay, or cell. And V is the potential difference which is produced, which is created across the ends of the resistors or across these 2 points A and B. Okay, so this is done. Now what we can do is we can actually find out the value of I from here. I is equals to V upon RP, and this value we can substitute here. V upon RP is equal to V upon R1 plus V upon R2 plus V upon R3. Now from here what we can do, we can take, see, we can write it like this: 1 upon Rp. V is common, so we can write 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, and then you know that this V and V will cancel, so we'll be getting 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, and this is the resultant of parallel combination of resistors. Okay, so this is the expression for resultant resistance of parallel combination of resistors. Now there are two important points in this particular one also. Do remember that in parallel combination of resistors, what remains constant? Potential V remains constant. Okay, what remains constant? V remains constant. And secondly, what gets divided? Current I gets divided. Current gets divided. Current gets divided. So two important points also we discussed in parallel combination of resistors. First important point is potential remains constant across these 2 points A and B, and the second one is current, it gets divided. Current is getting divided. Okay, in series combination, you know that the current remains constant and potential gets divided. Just opposite of that is happening here in parallel combination. Here V remains constant, that is potential difference. Potential difference, it remains constant, and I, that is current, is getting divided. Okay, so these are two extremely important points which you are supposed to know. Okay, and this is what the expression for the parallel combination of resistors. So I am just highlighting this particular one. So this is the expression for parallel combination of resistors. I hope that this expression and the derivation is clear to you. Thank you.